Hello everyone. Welcome to this Technology Radar webinar. As you may know, Thoughtworks, that is the global technology consultancy, we are present in 16 countries, and twice a year we publish the Tech Radar. The Tech Radar is our opinionated guide of the technology trends based on our experiences in the teams we have around the world. Today, we will give you a sneak peek of the latest version to be released soon. Who will join today is Birgitta, Ian, and myself. I'm going to introduce myself first, and then I will let them to introduce themselves. I am Karina Mora. I am a tech principal at Thoughtworks. I've been in Thoughtworks for more than 8 years now. I have worked in different business contexts. I had played multiple roles: developer, technical lead, architect, strategic advisor, and I'm very passionate about the consultancy on the strategy level. Then Birgitta and Ian, please feel free to introduce yourselves. Birgitta.
Yeah, hi everybody. I'm Birgitta. I'm from Germany. I work for Thoughtworks in Berlin, Germany. And I mean, my official title, as you can see here in Thoughtworks, is technical principal, which means in practice that similar what Karina just listed. Like I'm a developer by trade and by heart, I would say. But then, you know, playing different roles like a tech lead, architect, you know, working on technology strategies with our clients, those types of things. And I am, same as Ian, part of the group that curates the technology radar based on the proposals we get from Thoughtworkers all around the world.
Thank you, Birgitta. Ian, can you go?
Hi everybody. Thanks for joining us. I'm Ian Cartwright. I'm based in Manchester in the UK. I'm a technical director in professional services at Thoughtworks. So do a lot of work with our clients around strategy and technology. I'm also part of the group that puts the radar together. I'm lucky enough to have been involved in all the editions over the last 10 years, which has been an amazing journey.
Great, thank you both. So probably you are familiar with the Tech Radar. Now Ian will talk about how it is built.
Yes, so we're just going to be talking about some of the blips on the radar today, but to give you a flavor of what the radar as a whole looks like. So we have our 4 quadrants, and then each quadrant is split into rings. So if we start in the middle, we have a dot, and really this is a technology, a tool, technique, a language, or a framework that we feel giving a similar context is just the right thing to use in those circumstances. The next ring out we have is trial. So this is something that we think is worth trying out on a single project to start with. Don't try it out on all the projects next week, but try it out on a single project and see if it works for you. And there's an important caveat for us there that we will not put anything in trial that we haven't used in production, because we don't think it's responsible of us to suggest other people try things out that we ourselves haven't used in production. So that's trial. Then next we get to assess. So these are things, if you like, that are more up and coming, that they're interesting, but they're not maybe ready for use just yet. But they're definitely things that are worth keeping an eye on, maybe just doing a bit of an assessment, whether they're ready for you or not. And quite often what happens with the radar, things that we have on assess, later on they might move into trial or adopt, although that doesn't happen automatically. And then finally, the outermost ring we have is hold. And these are things that we're sort of recommending on the whole, approach with caution or don't use. And that is based upon, as are all the blips on our radar, it's based upon the feedback from our teams on the ground. So we don't just put things on hold because we don't like it for some reason. It's because we've had feedback from our clients and from our teams that these are things that get in the way, they make things painful or difficult. And so we're sort of sharing that learning with you all by putting them on hold. So that's the radar at a glance. When you see the full radar, all of that will make a lot more sense, I think, if you haven't seen it before.
And maybe
Okay,
one thing
thank
to
you.
add, right? Like a frequently asked question. So this is like not a comprehensive market analysis, right? This is always a snapshot of what we see at a point in time. So that's why you might not see certain things on it. They might have been on there historically, or we might just not have had a chance to try them. So I think that's like a frequently asked question. So maybe also worth mentioning.
Yes, thank you. And just before we move on, also to say that we don't have any sponsorships or partner relationships that require us to recommend a technology. So we quite often get approached by companies who say, hey, can we partner with you and you can put all our things in Adopt? We don't do that. The only way to get things on our radar is for our teams on the ground to be excited or the opposite, not very happy with the tech.
Let's move on. So the idea today is basically review some of the blips you will get in the published version. And we will begin with Birgitta with tactical forking, and we will have the questions to the end. So feel free to add in the questions and answers, and we will cover them at the end. Okay?
Yeah, and also related to the question about the slides, this is about the extent of what our slides will be in terms of detail. So it's really like worth more waiting for the actual edition of the radar, where it will have a lot more details. And Ian and I just chose 8 blips. So blip is kind of in the radar metaphor what we call the entries on the radar. And it's just 8 of them that we find interesting to talk about. And we try to find some of different areas, like some front end, some infrastructure, some data. So you will get a bit of whiplash maybe with the different topics, but we also hope that there's maybe something interesting for everybody. And I want to start with a blip from our quadrant techniques. So this is from the area of architecture, evolution, architecture, migration approaches. So when organizations try to scale and like change their architecture in a way that multiple teams can work on them in parallel, there are like many strategies, you know, when you have like a large code base, or, you know, some people call them a monolith, right? And you want to split it into multiple parts that are independently deployable and independently maintainable. There are strategies like strangler fig approach you might have heard of, written up by our colleague Martin Fowler, or branch by abstraction. So approaches like that. And some people also modularize their big code base first, and some do not do that. And one approach that we feel is often overlooked is this what we call the tactical forking. So instead of immediately trying to split up your code base or modularizing it, sometimes it's worth considering if you can duplicate your existing large code base. And then you have you duplicate everything. You duplicate the code, the pipelines, all of the things around it. And then you have 2 teams owning that code base, and they kind of strip it down to exactly what they need to own the different parts of it. So basically duplicate and then kind of chisel it down. And so this, I guess, depends on multiple things. You know, if this is like worth considering, depends on maybe the amount of commonly shared code maybe that's in there, or also the quality and existing modularity of your code. And also something to consider is, of course, that in this case, you still have those 2 code bases, or those 2 deployables share the same database, right? So it's also worth considering if that's what you want to do, keep the database as one first, and then in the future kind of start splitting it up, or if you would prefer maybe in your case, you know, with something like strangler fig, bit by bit, also splitting up the database. So this is definitely like a tactical step, right, on the way to an end goal of where you maybe also want to modernize the technologies you have in there. But in some cases, this might make sense. And yeah, we've just seen like many people not even consider this, but go for the modularization first. But in some cases, this can be a really good tactical first step.
Yeah, thank you, Birgitta. I think it sounds very similar to some of the challenges I have seen in teams, right? How to make this re-architecture while we have some backlog to work on, right? Okay, let's go to Ian, TinyML.
So TinyML is also in techniques in Assess. So over the years, we've seen more and more adoption of machine learning techniques, especially things around TensorFlow is one of the most common one, deep learning techniques, where you've got the model generation, you create your model, then you take your model and you run that and you use it to perform some sort of pattern recognition, for example. So what the idea of TinyML is to try and produce models that are optimized to run on quite constrained environments. So quite often, when especially when we talk about neural networks and things like TensorFlow, there's an expectation that there's big, expensive, high-powered hardware is required. And this technique says, well, actually, you can produce models, you can apply some techniques, and there's a website that describes them, that allow you to produce models that run in much more constrained environments. So this is really interesting because it sort of opens up a possibility of making use of some of this technology where you otherwise wouldn't consider it. So a few years ago, I worked with an organization who was using machine vision, and it was to do with the management of livestock on farms. And they had some very remote rural places in the United States where they were trying to implement this technology. And bandwidth, power interruptions were a real problem. And they also had to deploy some expensive hardware that needed special cooling and all the rest of it. Whereas one possibility now is they could apply, might have been able to apply this technique and come up with a model that could run on a much more constrained environment. So we think it's really interesting to assess. It's not in trial yet, but we think if you're looking at machine learning and maybe hesitating because you're thinking perhaps there isn't the bandwidth or the power at the locations, then this might be something to consider using as an alternative approach.
Okay, thank you, Ian. We will move to the next one. Software bill of materials with Birgitta.
Mm-hmm. Yeah, we're now getting into the world of the software supply chain. So software bill of materials is something that we already blipped in our last edition of the radar, but I want to use this as an opportunity to point to a few other things that we are putting on the radar this time. So first, maybe software bill of materials, what does it mean? So, I mean, the term bill of materials is inspired from the production world, you know, it's kind of like an inventory of all the things that you need to put together a product. And in the world of software, this is about, for example, the libraries that you use, the container images you use, the tools you use in the pipeline to actually put together the software. So all of those things. And last time when we blipped this, this got on our radar, no pun intended, because there was actually from the US, from the government there was an executive order on cybersecurity that actually mentioned this as a must-have for all software built for the government and the general, you know, public services, that they all need now to have a software bill of materials. And not only that, but also like lots of prominent, you know, exploits and vulnerabilities that have all affected us in the past year or two, in particular, like, you know, the most recent one, the big Log4j vulnerability. That has apparently triggered a lot more activity in this space, also in terms of tooling. So one thing that you're going to find on the radar this time is Cyclone DX. So which is basically a standard driven from also the OWASP, the security community, of how to describe a software bill of materials. So, you know, they basically defined a meta model for it and a format, you know, where you can describe the components, the dependencies involved, even the vulnerabilities if you want to. And this, this new format is a lot more extensive than the formats that were available before. And then you have now tools coming up like SYFT, SYFT, which is a tool that helps you then generate these software bill of material files automatically. So you can do that in your pipeline and, for example, point it at a container image and have SYFT basically spit out a JSON file in this Cyclone DX format, for example. that just lists you, these are all the dependencies of this container image. These are all the licenses that are involved. And then you have like a parsable format, machine parsable format of all of these things. And you don't have to, do all this manual documentation of the things that you're using there. And then if you, in addition to that, combine it with other tools, you can also include vulnerabilities in these bills of materials, or you can even use them with other tools, to like a tool like Gripe, which we also put on the radar, GRYPE, which is a new vulnerability scanner, similar to other tools available already. And this tool can also take a software bill of material file that has all of the, dependencies, components, and then based on that, tell you in all of those things that you depend on, where are the vulnerabilities. So it can use that file as a basis for telling you the vulnerabilities. And then you can combine it with other tools to even like assign, this software bill of materials file, which then can give people who maybe need to use your software, can give them even more trust and confidence that that they actually have transparency about what is included and what they are using. So there's a whole ecosystem starting up there with tools that should hopefully make all of this management of licenses, vulnerabilities, dependencies easier for us in the future and create that transparency, machine readable transparency. So I find that really exciting.
Thank you, Birgitta. I think that the example you provide from Log4j, I think it will be, people will feel related to what they see, right? And having this information already will improve the governance you have around your assets. Yeah. Great.
It doesn't automatically fix your Log4j problem, but if you'd had it, it might have very quickly told you exactly where you need to fix something, right? Yeah.
Great. Let's move to the next one, SPA by default.
Yes, so this is single page application by default. So if somebody's building a website and it's on hold, it's in techniques. So why have we put this on hold? So what we're seeing is quite common now is that when a team starts out to build some sort of website, they assume right from the beginning that they will build a single page application. It's almost like they default to that decision. And then what they do is the conversation becomes, which framework are we going to use to build our single page application? And what we're sort of calling out is maybe you don't need SPA, maybe you don't need that extra complexity right from day one. And there are extra complexities. I think just for example, things like initial page load speed for SPA can be much higher, or search engine optimization can be problematic because of the amount of JavaScript and so on. So you have to apply special techniques there. Even in some cases, doing some special server-side rendering just for the search engines. So there's additional complications from choosing to do a single page application. So what we're sort of saying is don't default to that right at the beginning. Maybe what you need to do is find out some more information or ask whether you really need it. And perhaps, just start by writing some plain HTML, some very lightweight JavaScript. And then as you go on, you might discover that you do need SPA, at which point you can bring a framework in. And it's much easier to add a framework later than to take a framework out later on. That almost never happens. And in fact, we often see people who want to move framework end up more often than not, they'll do a rewrite of the app because it can be so challenging to pull a framework out for an existing website. So what we're really sort of saying is wait for the last responsible moment to make that decision. And the last responsible moment isn't the first day of the project. There's often this pressure to make these decisions, oh, we need to say which framework we're going to use at the point at which we know least. When we're on a project, the point at which we have the least amount of information is almost always the start. And it's not until we start to build things, we start to talk more to our customers, maybe get some initial feedback from them. Then we have a lot more information about what we really need to build to meet their requirements. And then at that point, maybe that's a better point to make the decision that we want to move towards a single page application. So really, if you like, this is part of a general pattern that we see, that there's often a temptation with technology to try and make all the decisions at the beginning. And this is one example of where we're saying, yeah, maybe it's worth waiting, maybe get some more information, maybe do some spikes, do a few prototypes, get some feedback, and then make a decision later on. So that's SPA by default on hold.
And Ian, we also discussed in the group, right, like many of the things you just said are applicable to a lot of technologies, right? Like kind of like look for a use case. But the reason why we still decided to call this out is because there seems to be this whole generation of software development that has never built front ends with something other than a single page application framework, right? So that's why we felt it's worth calling it out, because there are different alternatives now popping up again as well.
For sure, this particular instance of this behavior has become very prevalent, I think, that it is genuinely a default for many people.
Okay, thank you. Let's move on to the next one, rethinking remote stand-ups.
Yeah, so this is now from the category of like teamwork, team collaboration. So, I mean, maybe the obvious thing, but to introduce this idea of stand-up, right? Like the reason why this also sometimes called daily, the meeting that teams have every day to sync up. And, you know, a usual way to do it is to look at your team board and go through it and see what work is in progress, give quick updates. And this term stand-up originally came from the idea, you know, of trying to keep it short, right? So the idea of everybody standing up, so it's a bit less comfortable physically, so you can keep it short, right? So what some of our teams have now discovered is that with, you know, so many of us working remotely, and many of our teams were co-located before the pandemic, and so many of them working remotely, they now realize this idea of short stand-ups is often not sufficient. It cannot be the only sync point during the day, because then people are also, you know, out of sight, out of mind. They might not see each other for the rest of the day, right? So many of our teams are experimenting with having a longer slot blocked with each other for this daily sync, and then using it for not only walking through their team wall and seeing what the status of the work is, but also using it maybe in the beginning for a bit of socializing, everybody coming in, and then also after walking through the wall, also having quick sync ups on little decisions they need to take, you know, things that are coming up in the day where they need somebody else's input. So there's like a loose agenda prepared beforehand to do a lot of the little syncs that were a lot easier to do when people were co-located in this time slot as well, and really have, for example, an hour blocked for this. And the goal is to actually make other meetings obsolete. So that is one of the goals. So if you cannot use the meeting successfully, so this extended daily sync, if you cannot use it successfully and reduce other meetings, then maybe it's not working. But yeah, those are two outcomes our teams are seeing: less meetings during the rest of the day and more team bonding through the slot as well. And this was actually in part inspired by a blog post from folks at Honeycomb. Some of you might have heard about that before, like it's an observability platform. And they also wrote about this as, let me see, what was their term? The meandering team sync. That's what they called it. So kind of like a little bit a loose daily sync that is also a bit longer.
Thank you, Birgitta. I think also the pandemic's condition has moved us to think about how we manage the remotely, like the remote interactions, right? Okay, let's move on to the next one, reusable workflow in GitHub Actions.
Yes, so a couple of radars ago, we put GitHub Actions on the radar. And for those who aren't familiar with it, if you're using GitHub now, what you can do, and this has been around for a while, on certain events that happen around your source code repository, you can trigger certain actions to happen, and those might be small trivial things, or actually, in some cases, third parties have created plugins So you might have checking some code or have some condition happen in GitHub, and that now will trigger that piece of integration to happen. And so we've seen a lot of teams in some circumstances that find that really very useful. And I'm going to come on to try and describe some of those circumstances shortly, but they found that very useful. But one of the drawbacks was if I created a bunch of actions, it was kind of hard. I sort of had to do a bit of a cut and paste and move them over to some new repository if I wanted to reuse them, or if I'd compose them together into a series of steps. And so what GitHub now have done, and I believe this is still a premium feature, is that you can capture those as a workflow and then reuse them in multiple places. So you can define a bunch of actions and say, actually, these are going to be standard for all of our microservice projects, for example, and then you got them as a reusable workflow. But there's a couple of things I sort of want to highlight, because we're seeing some interesting trends around sort of continuous integration or continuous delivery as a service. And we actually, quite a few radars ago, we blipped a couple of things which I still think are very relevant to this space. Now, in 2015, we put programming in your CI tool on hold. So what we were seeing was some of the CI tools at the time, quite often things that you would install on premise, had a very rich configuration, almost to the point where you sort of can create a programmable workflow through the configuration in your CI tool. Now, there's a couple of challenges with that. We started to get teams where that was the only place where they could test it, is in the CI tool. They could not test it outside of the tool because it's part of the configuration of the tool itself. So there was a challenge around testing it. And also in some cases, it wasn't possible to easily take that configuration and have it in source control. And so the challenge was, if you mess something up, and this has happened, you've got a very complicated configuration, and you go in and mess that up, it can be quite hard to recover that or to understand what changes have happened. So then you get in the situation where your build is broken, your continuous integration is failing, and is that because of the code, or is it because of the config, which has now become very complicated and difficult to understand? So we put that on hold. We were sort of saying, be careful how much logic you put into your continuous integration tools, because it's hard to test, it's hard to maintain. So that was one thing. So I think that advice is still very relevant when it comes to reusable workflows in GitHub. We still want to be thinking about, can we test it? Is it easy to understand, etc. Now, the other thing that we called out in 2016, and again, this was in the era of when we had mostly people installing CI on premise again, but we sort of called out a single CI instance for all the teams. So certainly when I first started with Thoughtworks and we were doing continuous integration, it almost always wasn't something that the tech ops or the IT department at our client supported. We'd often find a spare machine that would be under the desk somewhere with a monitor with a red or green to show us if the build's passing or not. And that was quite common, and different teams might have different setups. And then at some point, a lot of organizations realized, CI's got a lot of value, and it doesn't make sense for every team to be maintaining and setting up their own server or different CI software. So they started to consolidate. But the challenge then, we got to a single instance, a single shared instance. And there was two problems with that. One was, because it was being used by a lot of teams, you had to have some process around making changes to it. Because at the time, a lot of the tools weren't all that very good at being sort of multi-tenant. So you didn't want one team going in and messing up another team's build. So you get a degree of process. Maybe you have to raise a ticket to get a change made on the CI server. So that was one of the downsides. But the other one, and I think the one that is still very much worth considering, was that CI server, that single CI solution. If it's not unavailable, then potentially every development team in the whole company, or maybe in one geography within a company, can't release software. And in fact, if they're being a disciplined team and saying they're only checking in when they have a green build, when we know we've got all our tests passing, then actually your development teams could grind to a halt completely. They won't be able to get any work done because there's no build to tell them if all the tests pass when they're combined with other people's check-ins. So that's sort of where I'm going with this, with using GitHub, because what people have done with GitHub Actions and the reusable workflows is effectively move their continuous integration, and in some cases also their continuous deployment into GitHub. And now that's fine, but I think it's always worth asking the question, what if it's not available? What if GitHub's down for some reason? Or maybe we've got a network issue and we can't reach it. What's the impact for your organization? So I always think it's worth asking that question. You might say, it's fine. You know what, if we can't check out the latest version, the fact that we can't build and deploy it, we're willing to tolerate that. But earlier in this talk, we heard about a fairly urgent security issue where people wanted to be able to roll out and fix software very quickly because of the log4j issues. So I think it's always worth doing that little thought experiment. What if we had, a priority one security issue that means we want to build and ship the code, and what if at the same time, and I admit it would be pretty unlucky, but if at the same time GitHub was unavailable. And of course, this also applies for other CI servers in the cloud. And you might say, oh, well, that's not going to happen. It's not very probable. But maybe some of you remember there was a lot of DNS issues that happened last year with one of the big DNS providers. And that's caused quite a few websites to go down. And so we had a client and they were affected by this. And luckily, they realized there was a workaround that they could create. So they were releasing on a daily basis. So they made the change to the code, checked it in. The CI server, which was running in the cloud, run by a third party, was not reachable because of the same DNS issue. So that unfortunately for them, they couldn't release the code, they couldn't release the fix, and they just had to wait till the whole DNS issue got resolved. So I think for a little open source project or a few projects, using GitHub in this way is absolutely fine. For larger organizations where you started to get many, many teams, if you haven't done already, it's always worth just pausing and saying, oh, what's the impact? Have we got a way to run the build locally? Is the build tied to the GitHub Actions in a way that we can't run it locally? That might be something you'd want to address or have a look at. So it's in trial in the right circumstances. I think it's very useful, not just for things like CI or CD, but a note of caution, you're creating a dependency on a third party. And we often talk in Thoughtworks about software being a differentiator, software being a critical function of the business, being able to get software out the door. So you need to assess it from that point of view.
Yeah, we also had discussions in the group, Ian, right? Because that's actually still also, you will see when the radar comes out, multiple tools in this space actually on there. So there's still not like a clear, or maybe there shouldn't also be like a clear consolidation, right? But definitely just a few years ago, a lot of our teams were still hosting their CI/CD tooling themselves. And now there's definitely a lot more mature choices in software as a service, right? And also people often defaulting to what's in their current ecosystem. Like when they're on AWS, they're using AWS's tooling, or if they host their Git repositories on GitHub, they also use GitHub Actions, or, so that's, but at the same time, not all of these platforms are actually that mature also yet. So then you often have to take some limitations into account. So it's not quite like this, the perfect solution is sometimes hard to find here, right? And also what a lot of our teams find is that a lot of these software as a service tools don't support more complex pipelines well. So where you actually want to fork out your steps, run more things in parallel. So that is still something that is hard to find, where then a lot of teams need to make compromises.
Yeah, I think we've seen a similar trajectory with source control as well, where it was often not treated as production infrastructure. And this was quite common, where it was sort of maintained by maybe even some of the dev teams. It was on a single server. And I can think a long time ago now, we had quite a few clients where they were hosting things like Visual Source Safe themselves, and they had the problem with the disk or the machine itself. And they were suddenly realizing how key to their organization that was, that the impact in terms of costs of suddenly having a lot of development teams unable to work was not dissimilar from an outage on their production website that their clients used. And so I think that brought a shift in attitude to say, actually, you know, if we rely on a business on getting software out the door quickly, then the infrastructure we use to do that should be put on the same footing as production infrastructure that we use to run other parts of the business. So it's always worth something, just pausing and doing that little thought experiment. That what if question is always worth asking.
So after we just talked at length a little bit more for the other blips about the CI/CD space, my next one is actually going to be quite short, and I wanted to just talk about one of the little tools that we have on the radar, because it's sometimes fun to discover little new tools for productivity in the daily development work. And I don't know if somebody else is going to share the screen, but the tool I want to talk about is called JC. And it's basically a little command line tool that for a bunch of Unix commands, I don't know what the number was, like at least it supports at least 80 commands or something like that. And you can use JC, you can pipe the output of your Unix command into JC, and then it gives you a JSON formatted version of that. Yeah, there it is. Thank you. Which can be super helpful if you pipe that JSON output into JQ, which some of you might know. It's actually a quite widely used tool. It helps you parse on the command line. It helps you parse and kind of query JSON data, JSON formatted data, right? So if you have like Unix command that have sometimes, like really long outputs with lots of data, where you try with grep or all kinds of other things, you try to find the information that you need with JC and the JSON format, it can actually give you much more powerful tooling to really find what you need to debug things, to use in scripts in your pipeline and so on. So I found it quite neat. And I'm going to try and see if I can find an opportunity to use it for something.
I think one little caveat is if you are thinking to use it in a deployment, make sure it's installed. It's not installed on a lot of Unix distributions by default, but it's in most of the major package managers now. Yeah. So that's, and
maybe very quick, because I just see like a question in the chat to us as well. Maybe I should also give an example. So what I mean by Unix tools. So if you, for example, use LSOF or ifconfig or what else is supported. So there's a whole bunch of like about 90 common Unix commands that it supports. And then you can pipe the output of that into JC, and then it will give you the JSON formatted result of that command. I hope that makes it a bit more clear. Yeah, so then Gareth, yeah, we can move on to the last one, Ian.
Yeah, so Infracost. So this one is quite close to my heart, so to speak. So I've been spending a lot of time, I guess, over probably the last decade, advising clients on moving into the cloud and getting off some of their older legacy technology and moving on from on-prem into cloud. And one of the challenges we've seen with that is with on-prem, there's often a team, there's a finite set of resources, and so there's a well-defined process. If you want a new machine, or some new infrastructure or a network change or something like that, or some new storage, some new database, there was a well-defined process. Now, I'll be honest, it was often a process that led to frustration and delay, where, a project there was a virtual machine, but there's not enough capacity. So suddenly your project, because you were the next new one, you're being asked to pay for a whole load of new hardware because they've run out, or the database servers at capacity, or whatever it might be. So there was a process. It was often painful and sort of ticket-based. And then what happened is a lot of organizations, for various reasons, and there's a whole different topic there, but for various reasons, they decided to move to the cloud. But what often happened, unfortunately, is they went from where they had a well-defined process to sort of just relying on the teams to be sensible and applying a degree of discipline to how they were working. And that hasn't always happened. A few years ago, I was working with a client where they had really delegated the responsibility to development teams. And so the dev teams had taken that on, but they'd taken on the ownership, not the responsibility, if you like. So what they were doing was creating lots and lots of instances. The solution was always, well, just spin up another machine. And we did some work with that client, and we realized they were trending towards £1 million per month on cloud infrastructure, which is pretty scary. That's a big number. And that actually inspired us. In 2018, we sort of called out on the radar cloud run cost, or run cost as an architectural fitness function, and sort of trying to encourage teams, you know, if you've got the ability now to deploy into the cloud, you should track the cost. You know, you should understand, if you're looking after a series of microservices, the APIs are there, the data's there, we can use things like tagging, and we can know exactly how much it's costing to run something. And that sort of brings me on to, finally, you might say, but it brings me on to Infracost. So what Infracost will do is, if you're using Terraform, you can do things like, when you, on a pull request for different cloud providers, it will estimate the changing cost. So if you've got an existing Terraform script and you make a change to it, this tool will give you a delta, say, well, that will be $200 a month less, or $200 a month more. And so it's a tool that allows teams, again, to take some ownership and understand the sort of changes they're making. And it's interesting because it also highlights another behavior that we've seen. So I was sort of describing where teams are just going off and deploying machines, never turning them off again, creating huge bills, not taking responsibility for that, not tracking it. The other thing we've seen with cloud migrations is organizations take what was a fixed infrastructure in the data center, and they sort of replicate that architecture and that approach in the cloud, and it's fixed and it doesn't change. Because when they had on-prem, they would do something, a major restructuring of the data center would be something that would happen maybe every 5 years or maybe every 3 years. But they're applying that same mindset to the cloud. And the challenge there is, if you like, twofold. One is, there's always new services becoming available on the cloud. And it could well be that if you were to use one of those new services, you could get higher uptime, or you could have a lower bill, or you could be able to make changes faster. So actually, you want the ability to make changes when you're in the cloud, and you want to take advantage of it. And the other thing that we see is organizations don't see, they move to the cloud and they do what we call a lift and shift, which is effectively take what they had and sort of replicate that from the physical architecture all the way up to the software architecture. They replicate that in the cloud. And then they don't see the benefits. In fact, in some cases, it's more expensive to run it in the cloud than it was to run it on-prem. And then the puzzling thing is they don't take advantage of the fact that you can change that cloud setup, right? I could change my Terraform script if that's how I deployed into the cloud, and I could rework things, I could refactor things. I could do a sort of green-blue style where I create a new production environment, move over, make sure everything's running. It's a new environment that's cheaper, then I can turn the old one off. And so there's all these things we can do with the cloud that doesn't always happen. But if you do automate your cloud deployments using Terraform, here's a brilliant tool. It can allow you to get a feel for what that delta is going to be, and then you can start to do what some of the more mature folks do in the cloud, which is then to refactor to save money. So what they're doing on a regular basis is looking at their cloud bill, looking at the resources they're using, and they're refactoring their architecture in the cloud to make their bills smaller and adjusting based on the load, etc. that they see. So lots of really interesting things you can do once you accept that the cloud is more mutable and easier to change than your data center.
Great, thank you. So let's move on to the question sections. I think we have a good amount of time.
Yeah, and because Karina got kicked out temporarily, she cannot see the questions, unfortunately, anymore. So, but I had a look, Ian, so I'll try to pick out some questions for us here at the end. And I also want to quickly say there's some like love in the chat for the interpretation and the sign language interpretation. And yeah, I definitely, I hope we didn't speak too fast and all those technical terms. So also kudos for me, like to all those technical terms and interpreting that. Thanks. Yeah, so there were a few questions around SBOM or software bill of materials. So maybe I'll start with that. So somebody was asking, would it be accurate to say we already have this capability in the Java world with Maven's dependency list plugin and OWASP's dependency check plugin? So yes, I would say we partially have these capabilities, and we've also in a lot of places been doing this type of thing, right? A simple example would be a lot of the mobile apps where there's always somewhere hidden is like a page that lists all of the dependencies. It's kind of a bill of materials for users of the software to see what is actually included, right? So I think what's now happening is like a new level of maturity and integratability of all of these things. So especially if you look at something like Cyclone DX, which I mentioned, that gives you, that is trying to create a standard, right, for all of us to use. And that is also a lot more rich than listing some dependencies here and listing some vulnerabilities there. And then you have different tools that support that standard and you can plug them into each other. Or if you actually use it to give users of your software transparency of what you're using, then you know, you have the standard to rely on so that you know that they can actually read this standard. So I think that's what's happening, an additional level of maturity. And somebody else was also mentioning, I was just saying, creating transparency of what your software uses. Somebody else was mentioning that unfortunately publicly accessible software bill of materials sound like a convenient way for hackers to find vulnerabilities in the versions you're using, which might give them information, right? That's always tricky about security, right? Like on the one hand, transparency actually gives us more security because then more people will tell us what's going wrong and we can fix it. On the other hand, it also gives information to attackers. Yeah, that's something to consider depending on what type of software you have and how you publish it. Yeah. Let me see.
Yeah, I remember somebody asked about the tactical forking, if it is related to any specific architecture or to any specific domain of size of the repository, I think.
Yeah, no, I don't think so. I guess it becomes less viable the bigger your code base is, right? Because the idea is that each of the teams that then gets one of the copies chisels it down to what functionalities they are owning and deploying. So I guess the bigger it gets, that would be one of my criteria.
Yeah, I think what I'd add as well is perhaps before embarking on this, having a look at some of the metrics around the code. So if there are tools available for the language you're using, maybe some static code analysis tools, things like, I think, cyclomatic complexity, but also coupling. Because if you have a very tightly coupled monolithic code base, it could be quite, yes, you could tactically fork it, but because there's so many dependencies, you'll end up with effectively needing everything. You won't be able to easily chip out or sort of carve out one part because it's coupled into everything else. And so I would definitely say before, and actually, you know, if you're looking at a big monolithic code base and you're looking for different strategies, I think running some basic code metrics on that, and we find doing things like heat maps is especially useful to get, because an overall figure might tell you it tells you your average complexity, but it doesn't show you where the hotspots are, and the same for coupling. And so having some sort of map, some sort of heat map of a monolithic code base, and then saying, oh, right, we have a clear division here. So actually maybe tactical forking, we can see this thing here is reasonably self-contained. It doesn't have too many couplings to classes elsewhere in the code base. And so that might be something that where this pattern could be applicable and easier to apply.
It's definitely more useful for code bases that are already relatively modularized, right? And that also relates to another question here about tactical forking, which is, doesn't duplicating the code offer a great recipe for divergence and maintaining the same assets multiple times? So that's definitely something to consider, but only to a certain degree. I think it's also, you'll probably have some common, more boilerplate technical code that you will always copy and not separate, right? And it might be okay, right? So it's always this like trade-off between the autonomy that teams have to move forward and to deploy independently versus this, like, you know, is this too much duplicate effort, you know, these things diverging from each other. It's the whole discussion around, you know, how much code do you want to share between teams, right? And this trade-off between autonomy and the coordination and collaboration you need between teams on that shared code, right? So as always, it depends, right? But it definitely, it's definitely less problematic when you have boilerplate technical code that you duplicate. It's a lot more problematic when you have a lot of domain business logic code that you duplicate and then both teams are still running it and you have to coordinate that. Maybe we can go to another blip that we talked about and questions around it.
There was a question right at the beginning about building your own radar and tools for that. So actually on the Thoughtworks website, there is a bit of a guide to doing that. So that's definitely something we've seen quite a lot of organizations have done. So I'll share that with everybody in the chat. That will actually, if you follow some of the links, there's actually on GitHub, there's a code base for helping generate the visualizations. And although the example on the website uses, I think, Excel, there are other ways that you can feed data into that tool. And we actually use that to some degree ourselves when we internally inside of Thoughtworks when we build our visualization of the radar. So there's definitely some useful tools. What I would say is where we find the radar exercises the most useful when we do them with clients is you've got to make sure you're getting feedback from on the ground, from teams on the ground. We've seen a few organizations where they'll run a radar exercise with their architects who aren't really perhaps writing code anymore. And the problem is that it's not then being informed by whether a particular tool creates a bunch of pain for development teams day-to-day basis. So it's really important if you're going to do your own radar exercise to make sure you get people on the ground who live with these technology decisions day-to-day in the room giving that, well, or in the Zoom or the Teams call these days. We've also helped people, you know, we've facilitated sessions for clients as well, where they've wanted some support from folks who've run a lot of these sessions in the past.
Okay, I saw a couple of questions. I think we have time related to Infracost in relation to what is the benefit compared to getting estimates from crowd providers who already provide those estimates, and also how good it works in private clouds. Yeah,
so I suppose that, you know, when you're looking for cost estimates, having more than one source is often a good thing to compare. So maybe that's one benefit. Or maybe you're thinking, well, I've got some Terraform that's on one cloud provider. What might the cost be on another cloud provider? So it might be a way to find that out. But I would say, you know, and I think it's fairly common business practice that, you know, if you're after estimates on a cost, you get more than one and you compare them and try and understand why they're different. So that might be one reason. But quickly and easily being able to get costs from multiple providers is one advantage of the tool. And the second part of the question?
Yeah, it was related to using in private clouds. For example,
Yeah.
OpenShift.
I'm not sure. I think the challenge there is that and if you've got the costs available for that in terms of the infrastructure and because for the public clouds there's well-defined numbers attached to the cost of everything, and I quite often see folks who've built their own private cloud. They tend to have much coarser grain, so they might know the overall cost of their multiple data centers, but they won't know how much of that is running the databases or the electricity that goes to run the network switches and the cost of that. So I imagine it would be possible. I would go and have a look at this tool and see if it can help you, but I think the real challenge there will be that granularity of costing that you get from the public providers isn't always part of a private cloud. So it's much harder to get the actual numbers. You just get a very headline figure style of number instead, unfortunately.
Okay. In general terms, I see in the question also a lot of interest on more material, where to learn. They are asking about if there are some links to learn about software bill of materials. So I think if we can share. And also I remember somebody wrote that this concern about what happens if GitHub gets down, that it was like very similar to something that he wrote. So thank you people for bringing also those learnings that you have. I think we have a couple of minutes. There was one related with what we cover about the stand-up remote, right? If we have any thoughts about the pair and more programming in relation to remote hybrid work.
Mm-hmm. Yeah, we actually mentioned a few of those aspects in some previous editions of the radar. So one thing that actually, like with all the challenges, of course, with pair programming when you do it remotely with tools, right? Like tools are getting better. You don't always have to rely on like pixel sharing your screen. And so that is kind of like hard on the eyes and all of that, right? So there are definitely tooling challenges with pairing remotely. But on the other hand, also some people actually find it easier to pair remotely than pair when co-located, because you kind of like in your own bubble with each other, right? Without distractions around you. And they actually find it a lot more focused when you do it remotely than when you do it in a busy team space with also the physical limitations of sitting at the same desk and all of that, right? So there's pros and cons to that. And mob programming also, people actually find a bit easier remotely because there's less physical constraints. And we blipped a tool, I think last or the edition before last, that makes it easier to mob program because, you know, somebody writes a little change and then you can kind of with this tool, with Git, shift the current state of the change over to the next mob programmer. So there are also more tools now making mob remote programming easier.
Thank you. Thank you very much. I think we are getting to the time. Thank you for joining us today.